Okay, so today we're going to talk about the unit circle, and we unwrap the unit circle to make the sine wave and the cosine wave. So let's take a look at So Common Core, functions, trig functions for, and it says, you watching? Levi, you're watching? Use the unit circle to explain and graph periodicity of trig functions. It's like a period, isn't it? So we talked about the period. It's how wide, right? So the width of the curve, and we're also going to change the amplitude. Okay, so right off the bat, example number 1. Okay, it's not hard. Example number 1. Okay, I got my graph, right? Taylor, you not only don't have your graph, but you've got this one, right? So let's take this graph. Let's take our sine graph and make it twice as tall. That's all we're going to do. We're going to change the amplitude. Yeah, we did a little bit of this, and we're going to do a lot more of it in here, but luckily we've seen a little bit of this. Now, when I graph these, this is just the way I do it. I like to break it up into fourths, and you're going to see why. I like to do this. I like to go 1, 2, 3, 4 squares, and I think you're going to see why in a bit. I'll make that pi halves, 1, 2, 3, 4. Make that pi, 1, 2, 3, 4. 3 pi halves, and I'll go a little further. 1, 2, 3, 4, and I'll make that 2 pi. Okay, I like to go 4 squares, and you're going to see later on that a lot of these are broken into 4 sections. When you get done doing the 4 squares, right? 4 squares, 4 squares, 4 squares. Trust me on this, and I'll show you why I break it into 4 squares, okay, when you get done. So I went pi halves, pi, 3 pi halves, and 2 pi. Of course, those are all of the major points of my unit circle, right? I've got my zeros, my max, my 0, my min, right? Why do I do it break into 4? Well, if I take a look at the original graph itself, I've got the first part of the graph, right? The second part of the graph, the third part of the graph, and the fourth part. That's why I break it into 4s, okay? That makes sense, right? So then we just want to take this graph and stretch it to a -2. That's all we're going to do. So my answer is going to look like this. So let's put I'm going to put 1 right here, and I'll put 2 here. -1 and -2 here. So I can just stretch it, right? That's all I'm going to do is stretch it up to 2, -2. So I'm going to take this shape, stretch it from 2 to -2. That's all I'm going to do, okay? So it looks like this. At pi halves, it's up at 2. At pi, it's at 0. At 3 pi halves, it's at -2, and 2 pi, it's at 0, okay? So I just took my regular graph, and I stretched it. That's all I did. So it's going to look like this. So it has a changed amplitude of 2. Now it does keep going, so it's okay if we extend it if you want, and we will eventually extend them, right? Okay, the amplitude. What's the amplitude? 2 is correct. The amplitude is 2. What's the period? How wide is one curve? How wide is it from there to there? 2 pi. So the amplitude or the period is 2 pi. We didn't change the period at all, did we? We didn't squish it or stretch it. So the period here has to be the same period because we did not do any stretching or squishing, right? All right, number 3. We're going to do 2 things. We're going to take my cosine curve, which is this one. Oh, I'll take this one. Cosine curve. And we're going to make it 3 times as tall. But then I've got to put 2 curves in the place of 1. Okay? So at least let's go 1, 2, 3. Let's go 3, 1, 2, 3, -3, because I know I've got to stretch it 3 times as tall. Again, I'm going to put down my pi halves. My pi. I'm going to have to extend that. Pi, I've got my 3 pi halves, and then I'll go 2 pi, okay? And I just want you to watch. I'm going to put it on the board, but just watch, and then I will erase what I put up there. So I'm going to need 2 of these, and the shape looks like this. So to get 2 of them, they got to squish them like this. 1, see it? 1. Oh, I'm off by a little bit. Hold on. 1, 2. Okay, I got 2 of them in there, right? So if I'm going to do 2 curves accurately without making it look horrible like that, right? What I need to do is this. What's the new curve length? What's the new curve length? What's the new period? So the new curve length for this one is to take 2 pi. So new curve length. Let's take 2 pi because that's the standard 2 pi. And cut it in half. So we put half on one side and half on the other. So if I cut it in half, it tells me how wide each curve is, which is pi. So I need to draw my sine curve, one sine curve between 0 and pi. That goes up to 3 and down to -3. I'll say it again. We need one sine curve to go from 0 to pi, up to 3 down to -3, and then I need to do another one from pi to 2 pi, going up to 3 to -3, okay? So we know cosine looks like this, right? So we're going to take this shape right here and squish it into 0 to pi, okay? So it's going to start up at 3, right? And it's going to end at pi, okay? Because I'm going to take this shape beginning to end. But I know it has to go from 0 to pi, okay? I take this shape and I got to go from 0 to pi, okay? Now the bottom part of the cosine, or in the middle, has got to be down at -3. So it's going to go through the x-axis a fourth of the way. So it's going to look like this. Okay, there's one curve. There's one curve. The width of it is 0 to pi. It has an amplitude of 3 to -3, okay? The width of it is pi, and the amplitude is 3 to -3. Now I'm going to do another one because I need 2 of them, right? I really need 2 of them because the frequency is 2. So let's do another. It starts up at a height of 3. It's going to end at a height of 3. At 3 pi halves, it's going to be down at -3. Fourth of the way, it's going to be at 0, and at 0, and so here's my second curve. And of course it keeps going on and on and on if you want it to keep going on and on. But I really do have 2 curves. I have 2 full curves in the space of 2 pi. I have 2 full curves where I normally would have drawn 1. Does that make sense? I have 2 curves in the space of normally 1, okay? Now what's the period? First of all, amplitude. Amplitude, you guys agree, is 3, right? And the period. What's the period of one full curve? Pi. See that? One full curve, and we got the period anyways, pi, okay? See how it's pi? Okay, let's shift on up. Okay. Example 3. What do you think? What's going to happen? Give me some guesses. What does the negative mean? We're going to flip it upside down. So instead of it going up, it's going to go down then up, okay? So the negatives make it go upside down. So it's going to be upside down, or it's a reflection over the x-axis. Let's use some fancy math words. We're going to reflect it over the x-axis. And then 4, what's the 4 mean? Yeah, we're going to go down to 4 and then up to 4. So that's its amplitude, right? The amplitude's 4, not -4. Now what's the period? Well, we're going to take the normal 2 pi. We're going to divide it into 3 parts, right? So we're going to divide it into 3 parts. So a single curve is going to be squished between 0 and 2 pi. 2 pi thirds. So when I do my axes, be careful. I am not going to use pi, pi halves, 3 pi halves. I need to do thirds, okay? I need to do thirds. So because I have to go and squish one into thirds. So I'm going to go 1, 2, 3, 4. I'm going to go pi thirds. I got to do thirds because my period is in terms of 2 pi thirds. So I'm going to go pi thirds. I'll go at 2 pi thirds. I'll go 3 pi thirds. Well, that's just pi, isn't it? Oh, let's extend this. Let's see, where's my ruler? Yeah, I don't know. Extend this. Here, I'll use this thing. What's that? They gave this to me for a reason, didn't they? There you go. I'll have to guesstimate a little bit. So 1/3, 2/3, 3/3, 4 pi thirds, 5 pi thirds, and then 6 pi thirds is 2 pi. Okay. So let's draw this. What am I going to do? I'll do a real quick sketch so you guys can see what I'm doing, okay? So I have to go between here and here for one curve, okay? Cosine curve, if you look on your chart, a normal cosine curve looks like this. That's a normal cosine curve. It has this shape, okay? Normal cosine curve has this shape. We're going to go upside down. We're going to fit this shape between here and here, okay? So it's going to look like this. We're going to go down to -4, 1, 2, 3, 4. We're going to start here. We're going to end here. We're going to be back up here. Okay, let me put it in so you guys can see it, okay? Here it is, just in blue, okay? Why is this the answer? A couple of things. One, it is this shape upside down. Do you agree? It's this shape right here upside down. Capiche? Okay, that's the negative. It goes from 4 to -4, right? Capiche on that one? Now, the width of this thing has to be 2 pi thirds because we took the normal 2 pi, we broke it into 3 parts because we need to get 3 curves in there. I'll say it again. We need to get 3 curves within the 2 pi, right? So how wide is each one? We divide it in thirds, so it's got to be 2 pi thirds. Okay, now let me erase this, and we're going to put this whole thing in there together, right? Erase, erase, erase. Okay, so let's go ahead and put that in. So here's my 4, my -4, and it's going to look like this. So the normal it's always helpful to have just in your mind what a cosine curve looks like. This is a cosine curve here, okay? So that's my shape, that's my cosine. So I'm going to be upside down though. So I do my dot to dot. That's why I like graph paper, and that's why I like to do it in force, okay? So I'm going to go one curve. See it? Let's do 2 more. Same shape. So we're going to repeat this pattern. Here to here, so I'm going to have the next one here at 4 pi thirds. Have a pi, it's going to be up there. I'm going to have an intersection there and there. So here's the second curve, okay? Now let's repeat that pattern again between 4 pi thirds and 2 pi. So there, 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 and there. So I have 3 curves. I have 3 curves within 2 pi. Capiche? 2 thumbs up, 1 thumb up, sideways, down. Okay?
So this 3x, is that 2/3 of pi, or is that just 1/3?
It means, the 3x means you need 3 curves. We need 3 full curves within its normal period. Good question. Okay, turn the page. Okay, all right. Oh, yeah, what is the period? It's 2 pi thirds. Right? Period's just 2 pi thirds. Turn the page. Okay, now this one, we got some work. This one we're going to do a shift. On this one we're going to do a horizontal. Okay, so I'm going to do 2 things. I'm going to use my pencil first to get the first curve, and then I'm going to shift it, okay? So, what do I need? I need a normal sine curve. Normal sine curve between 0 and 2 pi. So I'm going to put that down. I'm going to go pi halves, pi, 3 pi halves, 2 pi, right? And I'm going to go maybe 1, 2, -1, -2, okay? So I got my axes. I'm going to draw first just a normal sine curve. I'm just going to put this in, then I'll shift it, okay? I'm going to put this in, then I'm going to shift it. Okay, it does have an amplitude of 2. So in pencil, I'm going to draw my sine curve, and it's going to look like this. Here's just a normal sine curve, which we have in our notes, okay? There's no normal sine curve, okay? But it has an amplitude, 2 to -2, okay? So 2 to -2, there's my amplitude. So there's my 2 to -2, okay? Now I'm going to shift it, but I'm going to shift it backwards. I'm going to go to the left pi force. So we're going to go back pi force, because we go the opposite direction. Now pi force, how many squares on my graph, how many squares is pi fourth? It's 2 squares. So the easiest way to move pi force, because pi force is right there, isn't it? So the easiest way to move pi force is move every important point back to pi, or back pi force. So or 2 squares. So I move this important point to there. That's all I'm going to do. Shift the whole thing back pi force. This important point, boom, to there, okay? This point, boom, to there, okay? This point, boom, to there. Back 2 squares, which is pi force, boom, there, okay? And there's my graph. How's that? And I can erase my pencil if I want to, if it's just kind of annoying, or I can leave it in there, okay? Thumbs up on that one? That was pretty easy, agree? So we made it a height of 2 and negative 2. We didn't change its frequency at all. We did not change its width because there was no number there. So we didn't change its width. There was no number there, just one curve. And then we shift everything back by force, okay? All right. Example 5. We're going to do a bunch of things on this one. We are going to make it an amplitude of 3. So I better go 1, 2, 3 here, right? 1, 2, 3 here, okay? Better do that. I need 2 curves, so I need to figure out how wide. What's my new width? Well, my standard width is 2 pi, but I'm going to break that up into 2 parts. Okay, now this is important that you know how wide the curve is, right? If I'm going to get 2 curves in there, they both have to be pi wide. Pi makes 2 and 2 pi, okay? So my new width, or my new period, is pi, okay? Now, I'm going to shift, when I get done, I'm going to shift the whole thing forward pi force and up 1. Okay? I'm going to do this in 2 steps, okay? The first thing I'm going to do in my pencil is just this part right here, okay? I'm just in pencil going to write y equals a 3 cosine of 2x, which we've already done. We already did that one, didn't we? We did it right there, didn't we? We already did that one. So let's do that one again, okay? And then we're going to move it, okay? So, all right. Let's see. There's pi halves, pi, 3 pi halves, 2 pi, right? And I'm going to go ahead and just scratch that in. Okay, it starts 3, up at 3, down. Okay, so there's one of them. Okay, it starts at 3, ends at 3. Its minimum is at 3 halves at negative 3. Okay, so there it is. I've got 2 curves. I've got 2 cosine curves between 0 and 2 pi. I have 2 cosine curves between 0 and pi, and it goes up to an amplitude of 3 and negative 3. Now I'm going to move it. So every important point is going to move forward pi force, which is 2 squares, isn't it? I mean, pi force is here, and then up 1 square. So it's going to move forward pi force. Watch. Let's go pi force and up 1. 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 How's that? Yep. Okay, you ready? So, I'm going to move every important point forward, or to the right, pi force, and up 1. So I just went pi force, which is really 2 squares, right? So I went boom, boom. So I moved everything 2 squares to the right and up 1. 2 squares to the right, then 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 up 1. Okay, 2 squares to the right, and up 1. Okay, how's that? Thumbs up? 1, 2, thumbs, sideways. Okay, all right. Last one. Ooh, my goodness. So there's a hint about factoring the 2 out first, okay? The 2 right here, if you've noticed, has always been before the parentheses. See it? Check that one out. Isn't the 2 before the parentheses? And here well, there's nothing there, but then let's see about this one. Now, anyway, the 2 needs to be in front. So if I factor out the 2, I'm going to rewrite this equation. It's really going to be y equals, you ready? It's going to be a 3/4 cosine of 2 parentheses x plus, I took out the 2, so it would be pi thirds, okay? How am I doing? So, let me at least do this in 2 parts, right? First thing I'm going to graph is this one. I'm going to graph the y equals the 3/4 cosine of 2x. Okay, so we kind of almost did that one above in pencil, but the only difference is it's only going to have a height of 3/4. So I can adjust my scales anything I want, right, Gerardo? So Gerardo, right with me? Gerardo, give him a nudge. So how about if I make that 1, so I'm going by quarters, does that make sense? Make that 1, so I'm going by quarters. Make that -1, so I'm going by quarters, okay? And then we'll do our pi halves, right? Pi halves. Pi, 3 pi halves, 2 pi, right? Got it? And then I'm going to go ahead and draw it in. I know what a normal cosine curve looks like. This, right? That's a cosine curve. That's the shape of one cosine curve. I'm going to do this in pencil, but I'm going to have it 3/4 there, 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 there. So one cosine curve between 0 and pi. Okay, there's one. Right there. Boom, boom. Okay, got it? Now let's just move this. Now how far are we going to move it? Pi thirds. Now pi thirds is not really on my circle, is it? Okay. So this is pi fourths here. Pi thirds is about 3 squares. Okay, we're going to estimate. Pi thirds is about, if that's pi halves, actually I said that wrong. Pi thirds, if that's pi halves, that's pi fourths. So we're going to move it about 1.5 squares. Okay, about 1.5 squares is close to pi thirds. Okay, so 1.5 squares, right? And we're going to move it which way? Which way am I going to move it? Back, because it's the opposite, right? So we're going to move it that way because it's the opposite. Okay, so ready? 1.5 squares. So 1.5 squares puts me right about there. 1.5 squares puts me about there. 1.5 squares puts me right about there. Ooh, about there. It's 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 about there. Okay. There it is. And if I erase my pencil, there's the answer, right? Okay. You need to do this. You really do. And you need to do this while I'm here because this stuff's not easy, is it? Okay.